Start with the drill. I'm going to add one more to that. Remove brackets from this. And do that one without finding it in the bird book, please. Right, gents, let's have a look. What we part of the drill for this week is some bits and pieces that we covered last week, and then also some bits that introduce what we're going to do this week. So, and the one I added was one that was emailed to me, a question about dealing with nested brackets, brackets inside brackets. So the first one, x to the 5 times x to the minus 3. The process is, Ben, what do we do? Take what away? Okay, can't remember. Anyone else help? When we multiply, we add the powers together. Yeah? So we got to do what effectively that is x to the 5 plus minus 3. Yeah? So that's x to the 5 minus 3, which is x to the 2. Yeah. What about the next one, Adam? Y to the power 3 divided by y to the power minus 4. What's the process? Take the powers away. So we're looking at it being y to the 3 minus 4, which is y to the 7, yeah. Okay then, multiplying out the brackets over here, what would you do there? What? So the answer is 3x squared minus 7x. Yep. Sam, factorising the fourth one. You got to the third one, okay. Bon, what have you got for that one? So we've got to have a set of brackets because that's what it is. You've taken 5x on the outside, x squared minus 5x. Anyone done anything different to that? Yeah, you can take 5x squared outside the brackets. It's common to both terms. And then in the brackets, just x there and 5 there. If you multiply those brackets out, you get back to where you were. Okay? So that's part way towards the complete factorization, but that is as far as you can go. So that's kind of, and the extra one at the end, is dipping back into last week. So what about this one at the end here? What do we do? Lewis? Yeah. So you're going to go like this, 2b squared minus 3q minus 3 times minus 3r q squared Yeah. So we go 2p squared minus 3q, 6q, sorry, minus 6r plus 2q squared. So if you have no brackets now, is there? So if you have nested brackets, you have to work outwards from the inside. Right, Jack? Because that was you who emailed me and said you had having a little bit of a problem with that type of question. Okay, so that's what you do. You start from the innermost bracket, so you could possibly have 3, 4, or 5, even more sets of brackets. You start from the inside ones first, multiply them out, then the next outermost, and so on. Okay, so that's how you deal with nested brackets. So what about solvent? 3x plus 2 equals 14. Kyle, what do we do? Do you know? Anyone any ideas? So you subtract 2 from 14. So if we do that, we've got 3x plus 2 minus 2, because what we do to one side, we have to do to the other. This is the issue. It equals 14 minus 2. Plus 2 minus 2 cancel out. So what we've got is 3x is equal to 12. Yeah. I'm going through it step by step, so everyone in there. And then you divide both sides. Let's just move this down a bit. Then you divide both sides by 3. And those two 3's there cancel each other out. And you've got x is equal to 12 divided by 3, which is 4. Yeah. So along the same lines, what would you do with this second one? 7x minus 2 is equal to 3 plus 14. Add 2 to both sides. 7x is equal to, and that bit's 17 plus 2 is 19. And then divide both sides by 7. Yeah, okay, and those two cancel out. You end up with x is equal to 19 over 7, or that decimal number what Lewis just said. 3 point something, 2 point something, yeah. And like I said last week, try and be, if you can, be comfortable with leaving an answer as a fraction. And then especially if you're going to go on and use it again, you might want to write the final answer as a decimal if that's so many meters, but then if you use that again in another calculation, use the 19 over 7, because you're using the full accuracy, carrying the full accuracy through by using that fraction. Yeah? It's like some old hands use 22 over 7 for pi, because it's not rounded. Okay? Just leave it as pi right until the end. That's another point. If you've got pi in your formula, don't evaluate it right until the last minute. Just leave it as a constant, pi. And then the last one, make R the subject of the area for a formula. That formula is the area of a circle. Yeah, make R the subject. So how do we go about doing that? Yeah, so we do this. We divide both sides by pi, which cancels the pi out. I'm going to write it out. Got pi r squared on the top and pi on the bottom. Those two cancel to leave me with I'm going to write it on this side because I like to have what I'm looking for on the left hand side. I'm a bit like that. Is equal to a divided by pi. The next thing is, how do we get rid of the square? Take the square root of both sides. So we do that, and we do that, and square a number, then take the square root of it. What happens? They cancel out. So we end up with r is equal to square root of a over pi. And be careful to make sure that your square root sign implies that it is everything, that whole fraction square rooted. Yeah, because that sign right over there implies that there's brackets around there. On written maths you don't write it. In some cases you may need to put those brackets in on your calculator, so just be careful, because you don't want this part of that fraction straggling outside the square root sign. You'll get the wrong answer. Okay? So that's kind of loaded in a little bit to what we're going to do this week. Session 2, solving simple equations, rearranging formulae and equations, solving indicial equations using the laws of logarithms. So I haven't put that in the drill. I've left that one. Okay. Don't really matter. We'll do a little bit on that anyway later on. So that's my intended coverage for today, and then there's plenty of practice questions for you to have a go at towards the end of the session. So, solve. And we already had a go at one like this, so we'll have a go at that one. Solve 6x plus 1 equals 2x plus 9. Write the steps out. Get in the habit of writing the steps out, because you're going to be expected to do that in the exam, so that you can get credit for getting part of the question right, going part of the way and getting it right. Right, process. Where do we start? What do we do first to that, to solve it? Or what would you suggest we do first? I do first to solve that. Subtract 1 from both sides. So we're effectively doing 6x plus 1 minus 1 equals 2x plus 9 minus 1. And then we can bring together the fact that those two cancel out to make that 6x equals 2x plus 8. Everybody follow that so far? And eventually you won't need to write the simpler question out step by step. But at this stage, and I'm just going to write here, subtract 1 from both sides. So that's what we've done. Yeah? Next thing to do. Subtract 2x from both sides. Good. So we go, let's put here, subtract 2x. From both sides. So we go 6x minus 2x equals 2x plus 8 minus 2x. They cancel. And our equation becomes 4x equals 8. And the next bit is divide by 4. So Remember, anything is okay, any operation is okay, and sometimes later on with more complex stuff, you might not know what you need to do to get it where you want, but you try things. As long as you do the same thing to both sides, then the equation's still balanced. That's what it's about. If I put two apples on one side of a set of scales, as long as I put two equally weighted apples on the other side, those scales still be balanced. Yep. So we're going to divide both sides by 4. So we got 4x over 4 is equal to 8 over 4. The two 4's with the x cancel out. That becomes x is equal to 8 over 4, which is 2. And until you get really familiar and have done lots of practice, it is worthwhile writing out all the steps, and in some of the more complex questions in the exam, you're likely, if you make a mistake later on, writing out the steps and getting some of it right is going to get you some marks. Whereas if you just do the answer and get it wrong, I can't give you anything. There won't be a question as easy as that in this exam, mind, but there might be a bigger question that involves you needing to solve some kind of expression or equation. How about that one? What do we need to do to solve that? Any ideas? What's the first thing we need to do? Multiply out the brackets. Let's have a go then. What's the result of multiplying out those brackets? So we have multiply the brackets out. Yeah. Then take away 6 from each side. 3x minus 6 minus 6 equals 3. Minus 6 is 3x minus 12 equals 3. Needed to plus the 6 to get rid of it. Yeah? Because the 6 is subtracted, you need to add 6 rather than take it away. Alright? So we got 3x is equal to 15. I've kind of jumped a step there, I haven't written it all out. So what we've done is add 6 to both sides and got shorten both sides to BS. Okay. Next thing. Yeah, div BS by 3. Okay, so we go 3, 3, those two cancel to leave us with x, it's 15 over 3, which is 5. However, what you could have done right up the start, let's just do it over here, 3x minus 2 equals 9. brackets. Don't forget the brackets. The rules of broadness when we add up says we do inside the brackets first. What we could have done is divide by 3 straight off. Yeah, so we're going to go like this. Yeah, because that 3 is attached to that bracketed term by multiplication. So we divide these two 3's cancel out. The brackets can now go, are not needed anymore. So we got x minus 2 equals 9 over 3. 9 over 3, yeah. Which is 3. Okay. And then we add 2 to both sides. X is equal to 5. Neither way is right, more right or wrong than the other. Okay. Just happens there are 2 different ways that you could have tackled that particular problem. Because sometimes multiplying out the brackets would leave you with 2 terms in x, and that's not really what you want because you're looking for 1. So if an example where you had brackets that had got an x and an x squared term in it, multiplying out the brackets there would leave you with a term in x and a term in x squared, not necessarily what you're looking for. Okay, so in this instance, multiplying out the brackets first, or effectively, or doing it this way, was no different. Come up with the same answer. How can we check our answers to these problems? We found out x is equal to 5. How can we check it? X. So we substitute, replace what with? Yeah, in the original equation. So substitute x equals 5 into both sides of equation. So we can go left hand side, we've got 3 times 5 minus 2. What does that equal? 5 minus 2, we've got to do in the brackets first. 5 minus 2 is 3 times 3 is 9. Right hand side, the original equation, already equals 9. Yeah? So they're both equal when we substitute back in x is equal to 5. So there's a check there. If you're unsure, plug your answer back in the original equation and make sure they are equal to each other. You'll find a mistake if you've made one that way. How about that problem? How might you go about doing that one? Right guys, method to solve this problem. What would you suggest? Sharp. That's my quick way of doing it. Okay. If we take the inverse of both sides, i.e. we turn both the fractions upside down, we get x on the top. That's a good start. Inverse both sides. So what we can do is x over 3 is equal to 5 over 4. Yep. If I turn one fraction up the other way, as long as I do the other one, you could write a half is equal to 2 over 4. If I also write 2 divided by 1 is equal to 4 divided by 2, am I still right? Yes. And if you try that with any numbers, that'll still be true. So if you take the inverse of both sides, you turn both the fractions up the other way. What we've done, effectively done there, what's handy about what we've done there, is we've got x to the top. And what do we need to do now for that to become x is equal to something? Multiply by 3. So we end up with x is equal to 3 times 5 over 4, which is 15 over 4. All right. Now, I may come back to that question in a minute to look at doing it in a slightly different way, because how would you solve that problem? And again, short time for you to have a think about solving that problem. Right, what ideas have you got with regard to solving that problem? Anyone managed to get anywhere with it? No? What you tried then, Lewis? What answers have you got?
I've got one of them. I've got 43 over 15.
Okay, well neither of them are right. Okay, just quickly explain what you've tried.
First, I tried balancing all the 3 y's on one side.
So trying to get all the y's on one side. So what did you end up with?
I ended up, after I divided,
Presumably something like, did you try adding 3y over 2 to both sides, so adding the whole fraction?
yeah.
You did try that. Okay, so you've gone down the same denominator route. Yeah? Okay. Okay. What I'm going to do, right, is just go back to this initial example again for a minute. I'm going to clone that and get rid of what we did. Like that. And write that problem out again. 3 over x is equal to 4 over 5. This is the method from the Bird book. Okay. The lowest common multiple of the denominators here is x times 5, or 5x. Yep, that's right, it's 5x. We get that by multiplying the two denominators together. Yeah? And then, so if we multiply both sides, by 5x, we get this. 5x Yep. Now what can we do? What would happen if we multiply this bracket out? 15x over x, won't we? Yeah? And what about if we multiply this bracket out? (20x) over 5. What can happen over here? X divided by x is 1. They cancel out because x over x is 1. What can we do over here? 20 divided by 5 is, I better make that look like 20 divided by 5, don't I? So effectively what we've got is 15 is equal to 4x. Therefore, x is equal to 15 over 4. Where? No. It's 15. You're looking here, Lewis, yeah? What you've got, another way of writing that is 15 times x divided by x. And any number divided by itself is equal to 1. Yeah? 15 times 1 is 15. Alright? That's the idea of this cancelling, is you cancel them because x divided by x is equal to 1. Yeah? Okay? So, that's a long-winded method to solve that simple problem, but will that help us to solve that one? What's the lowest common multiple of all the denominators? Yeah, LCM here equals 20. So now, 5 minutes, have a go at that using the method we used on the previous example. What do we do first? Yeah, multiply by 20. So we're going to go 20 times 2y over 5 plus 20 times 3 over 4 plus 100 equals 1 minus 20 times 3y over 2. What the process is doing is helping us to get rid of the fractions in the problem. Because if we look now, 20 divided by 5 is 4 times 2y over 4. Not over 5 now, is it? 4, that becomes 4 times 2y. Times 3 over 4. 20 divided by 4 is 5 times 3 plus the 100 is equal to 1 minus 20 divided by 2 is 10 times 3y. We got rid of the fractions. That's the key to this. By multiplying by the common last common multiple, it gets rid of the fraction content. Now we can multiply out the brackets, can't we? Yep. So we got 8y plus 15 plus 100 is equal to 1 minus 30y. y plus 115 is 1 minus 30y. Where do we proceed to from there? You could do that, but what are you going to leave yourself with on this side? A negative 30y. Yeah? Would it not be better to add 30y to both sides? Yeah? So if you can avoid leaving a trailing negative sign, do that. So we're going to have effectively 38y. I'm going to jump a step now. You're all happy with me doing that? Not writing out 30 plus 8y plus 115 is equal to 1. Yep. Now next step. Remember, we want to find y, so what's the next step? Take 115 from both sides, so we end up with y, 38y, sorry, is equal to minus 114. Yeah. Y is equal to minus 114 over 38, which is minus 3. And if you plug that number back into the original equation, we find out that answer is correct. No, the y is a negative number, Dom. Yeah?
But there is 114 over minus 38. Same answer.
No. Because what you're going to end up with is you're going to take 1 from both sides, you'll leave minus 30y over this side.
Minus 38.
Yeah. And then what you're going to do is take 38. Hang on, just let me do your... So what you suggested here was subtract 1 from both sides, yeah? So you'd end up with 8y plus 114 minus 30y. 114 equals minus 38y. Divide through by minus 38. Yeah, you get the same answer. Okay, nothing wrong with doing it that way. But if you can avoid it, try not to end up with minus y is equal to something, because I find students get confused getting rid of that negative sign. Minus y is equal to 10. Yeah. If you end up like that, what you need to do is think, I'm going to multiply both sides by minus 1, and that will get rid of that sign in front of the y. Okay, but no doubt we'll come up against problems like that, where you do end up with a result that's negative. But if you can, try and avoid ending up with a negative sign up front that's easy to forget to put it in or forget it's there. All right. You would have still ended up with exactly the same answer. Okay? What we got on the next page? Okay. Transposing formula. So part of what we've been doing of solving these expressions leads into one of the nemesises of a lot of students that come on engineering, as they say, I can't get my head around this transposing formulae, where you've got a formula for something, like this one, V, the volume of a cylinder, is equal to pi times r squared, which is the formula for the area of the circle on the end, okay, and then if we multiply that by the length of that cylinder, we get the volume. Okay, so V is the subject to that formula, and the formula gives the volume in terms of the radius r and the length L of that cylinder. If we knew the volume and the radius but wanted to find the length, we would need to rearrange the formula to make L a subject. Okay, and it's much easier and more scientific and engineering correct to rearrange the formula first so you don't miss any numbers, and then put the numbers in once you've got the rearranged formula that says L equals something. In order to do that, we've already been doing some of this, the mathematical opposites or inverse operations. Can we add anything to that list? What we're saying here is the opposite of division is subtraction, and that's what we do. If it's added to one side and we want to move it, we subtract from both sides, and by subtracting the same number, they cancel out. So it's what cancels the other. So what can we add to that list? What's the opposite of multiply? And that's always a two-way thing. Divide. Yeah. So if a letter's attached by multiplication on one side, you can cancel it on that side by dividing that through by that particular value. Same as if that's divided, you can cancel by multiplying both sides by that value. What about square? X squared. Yeah. Square root of x squared. Sine x. Sorry? Inverse sine. On your calculator, that's sine to the -1 of x. Yeah, it's called the inverse sine. You've got the same thing for cos x. And tan x. Couple more. Log. When we write log that way, and we're going to come to these a bit later, we talk about log to the base 10. We don't normally write the 10 when you use common logarithms. We only put the base in if the base is a number other than 10. So log to the base 10 of x, the inverse of that, is 10 to the x. We'll look at that a bit later on in the lesson. Okay? ln, the natural logarithm of x, not today, but we will come across it at some point. The opposite of that is e to the x. If you look on your scientific calculators, these opposites are on the same key. If you look at the log button, the shift function is 10 to the x. If you look at the ln button, the shift function is e to the power of tan to the minus 1, and so on. The square and square root buttons, because they are so common, are separate buttons, so that goes away from that. But a lot of the more complex ones, like these ones down here, are actually on the same button on your calculator. The opposite is the shift function. Okay? And we'll meet some more mathematical opposites later on. Two particular ones are the methods of differentiation and integration in calculus, opposites of each other as well. Okay, so when you're looking to rearrange these formula, those are the tools available to you to move around and do your algebra and get that formula looking how you want it to be. But you'll also possibly be applying the rules we've already been looking at, factorising or multiplying out brackets, and following the laws of BIDMAS as well, doing things in the right order. Okay? So, make L the subject to that formula. What do we do? And at this stage we'll do it one step at a time. What would you do first? We want to get to L equals something. One convenient thing sometimes might be, although you might end up moving it anyway, is to write it with L pi and r squared on that side and v on that side. So you've already got the subject to the formula on the left hand side. Can be handy. How are these three attached to each other? Okay, you're going to do it all in one go, yeah. So what it is these are all multiplied, aren't they? Pi is attached to those two by multiplication. R is attached to L by multiplication. So we need to divide by pi r squared. Are you happy for me to do it in one go? Those two they're only two numbers. R squared is a number, pi is a number, multiplied together. We can shift them all in one go. Yeah? What we do to that side, we must do it to this side as well. Yeah? So we have divided by pi r squared. That means the pi's cancel out, because pi divided by pi is 1. And the r squareds cancel out, because r squared divided by r squared is also equal to 1. So we end up with a final formula of L is equal to v over pi r squared. That one's really easy. Yep. Okay. Happy for me to move on? No dissenting voices, off we go. They were earlier, but I think they were cleaning then. Should be alright. This is one of the equations of motion. Make U the subject. Make U the subject. Right, what we got to do, Adam? Subtract AT from both sides, yeah. Because A is a constant, T is a constant, and they're multiplied together, they just make one big number. So we can move them both in one go. So we can just go V minus AT equals U. And to be precise, we write it this way round. Okay. Anyone go down the route of saying they're going to subtract U from both sides and then do it in any kind of different way to that? Nothing wrong with that per se, but we always try to look for the easiest way to do things. Yep. Right, a common formula that you're going to come up against will be good old Pythagoras theorem. Z squared is equal to x squared plus y squared, where z is the hypotenuse and x and y are the other two sides of a right angle triangle. And we're asking to make x the subject. What we do first? Yeah, so what you've done there, Lewis, is sub y squared from both sides. Yeah. So you end up with x squared is equal to z squared minus y squared. Then yeah, so you do the square root of both sides. So you go square root of that, square root of all that, and that's important that you put that square root symbol over the whole thing, and it implies that there are brackets around that term, and you do everything in there first and then take the square root of the result. Okay, and then these two cancel each other out and you end up with x is equal to the square root of z squared minus y squared. Yeah, that is the formula for x. Because it says transpose the formula to find x. So you've got to have, if you're going to find x, you've got to have x on its own, with no squares, no cubes, no nothing, no square roots, just x. Yeah? Finally, before you go for have a break for a little while, transpose that formula to make A the subject, okay, and then we'll go through that one. And we'll have a bit of a break. So what we're going to do first then, we got P is equal to I squared x plus I squared y all over r. This one's a bit more of a kind of messy one to get your head round because we've got two lots of a at the moment. Usually if you get that, not always, you're probably looking at trying to factorise so you only got one lot. So what's the first operation you've tried? Move the r. How do we move the r? What do we need to do? Multiply both sides by r. Yep. So we get P r is a squared x plus a squared y. Yeah, so that's nice and neat. Next bit. Sorry? So what are you going to do to this side and that side to get the x over there? I'm going to do that process. It's not about, because there's a common, so you're saying divide by x, yeah? So what we've got to do is we've got to divide all of both sides by x. So what you're going to do is say that's PR over x that side is equal to a squared over x plus a squared over y. A squared y over x. Right? These two cancel out, but there's no x on the top there. So what you've ended up there with is equal to a squared plus a squared y over x. So you've compounded the problem now because you've got two lots of x as well as two lots of y, and the x's are on both sides. Quite a common or incorrect method there. What have we got? We're looking to find a, and we've got two lots of it. So what could we do? I'm going to leave that on, and I'm going to copy the page so that we can have another go. So that's that version. I'll just put not going to solve on there because we got two lots of x now, one on each side. So on this version, I'm going to get rid of that, write out what we had again. PR is equal to a squared x plus a squared y. Any other ideas about what we could do? Yeah. Factorise right hand side. So we'll still have PR on this side. And we want, we're outside the brackets, Lewis? A squared brackets x plus y. Oh, that'll look handy. What's the sign in between these two things, a squared and x plus y? Times. So dividing is right, but do we want a squared over that side on the bottom? Eventually you'll get to where you want to be. But remember, what is the brackets x plus y? X and y are what in terms of the real world? but what do they mean? They're numbers, but we don't know what they are. So they are, x and y could be two different numbers. They might even have the same value, but add them together, they're only one number. So we can move that bracketed term on block in one go.
Okay.
Yeah? Because that means a squared times everything in that bracket, we can now move that bracket all in one go. We can move the a squared if that was the right thing to move, but it's better to move for x plus y. Multiply, divide both sides by x plus y. So we end up with PR over here over x plus y is equal to a squared. And then the last little bit, we do square root of both sides. And those two cancel out. So we end up with a final formula of a is equal to the square root of PR over x plus y. And at first it is tricky to work out what to do first. Yeah? But generally where we've got two of the variable we're looking for, we're often looking at factorization so that we only end up with one of them, or cancelling in some way. And there's nothing wrong with, if you can't see, just try something, but it doesn't work, go back and start again. Yeah? Right.